Hello beautiful people, welcome to this tutorial. In this tutorial I want to show you how Go handles strings, surprises and best practices with Unicode. Now, Unicode is a very powerful system on how we handle characters from different languages in our program, especially if you work in an international environment where your software needs to support like Arabic, Chinese and many other characters that are outside the ASCII character set. This tutorial is for you. If you don't want to code along, sure, you can still watch the video. I think it's going to be a short video, so you just watch and enjoy. Now let me give you an example of what I think some of the problems are. So let's go create a main.go file, and the first thing I want to show you is this. Let's say I copy, let me bring in a Japanese character for hello, which I translated using Google, and then I print something like learn s, for instance, and then I can go and run this. As you can see, it's 15, but this is not 15, right? 1, 2, 3, 4, 5. So if you are building, for example, a web application, when we do validation, we usually do something like, let's say if it's greater than 5, we don't want to let the person in. Let's say username must be less than 5 or something, or less than or equal to 5, something like this, right? Then this is going to fail, right? Because for sure this is greater than 5 by default. So why is this so? This is why I'm making this tutorial, to show you some of the surprises. I call them surprises because if you're coming from other languages, you expect this thing to be 5. So let's start with some basic stuff and we can see how it goes, right? So let's start with this one. So why is this 15? Why does learn print 15? If you count the characters here, 1, 2, 3, 4, 5, that means this encode each character you are seeing here, each char equals, is using 3 bytes. And in Go, each of these, like this one for instance, is called a rune, right? This rune, which is very difficult to pronounce, by the way, it's is the individual characters that are put together to form a string. So you can imagine this as a, sort of a slice of runes, but although they are together now, then that is what form the string, right? Simple idea, great stuff. So we are saying 15 here because each of these characters is using 3 bytes for their encoding. If you want to test for the number of characters that are truly in this string, you cannot do this. So let's change it a little bit. So this is the length. So this is length. I need to type string, right? So this is length. We can do, let's change this to len in bytes. This is more accurate. Now, we can do the actual len by using UTF-8, this one, which is rune count in string. And we can run it, and you see this one is 5. This is correct. This is what the end user wants to see. The system is saying 15, which is okay because systems works in bytes and bits and all that, but for your customers, they don't really care about the bytes and bits. So this is one of the surprises that you have to keep in mind. Each time you want to count the number of characters in a string, this in Go, this is what you should use. Even if you have, for example, let's say hello world here, for instance, you should still use this. If you, for example, if I use only this, then both the len and the length in bytes and the characters would be the same, right? They are both 55 because this is using a single byte for the storage. And this is really interesting because the way Unicode works is, even though it's a larger encoding scheme, it starts with a single byte and up to 4 bytes or so, which means for the languages that uses single bytes like English, which uses mostly the ASCII tables, Unicode still brought them in and sort of create a very flexible encoding system, which is mostly, I think that is what most of the web use. So it is really powerful. When you are in the ASCII context, this is fine, this is enough. So that's it. All right, let's restore this one. So second thing I want to show is this. So let's come here. I can put this together and then, can we do this? Good. So this is example 1. Now example 2 is, let's say we have, let's bring this string again. And one of the ways, let's say we want to loop over this string and print the individual characters. It is possible, before I do this, let me use the hello world here. It is possible to do for I equals 0, I less than len s I plus plus, right? This is basic stuff, and then we can do s at index of I, and this is going to work, right? No surprises. Well, maybe there is one, because here instead of the character you are seeing numbers, which is okay. This is u int 8, unsigned integer 8. This is what you are saying. If you want to print the character itself, we can switch to printf and then char or char, and you can print it. And then you have the hello world. Of course, if you can put a new line here, run it, we have a hello world, right? Well, so far no surprises except for that numbers that were printed instead of the string itself. Alright, or characters rather. What if I change this to the Japanese characters and I run this program? Boom, it crashed. Not technically like crashing the program, but for sure it produced a different result. This is not the intended result. As you can see, it just prints gibberish, something unusable onto the screen. Okay, so this is a problem. Now, what you are seeing here is a problem with something called the Unicode code point. Go manages each character using something called a Unicode code point, and this flavor of loop does not account for that. That means it is trying to decide the individual characters using the length, and this is not correct. The length that is seen here is different. This is 15, and for sure we don't have 15 characters here. We only have 5 characters. Okay, what if we put 5 here instead? 1 to 0, from 0 to 5. So what if we do that? Since we know still yet we didn't get the correct result. Now this is a really big problem. Each time you want to loop over a string, don't do this. Instead, so let's restore the length. Instead, you do something like this. For this is the index, and then let's say the room equal to range s. Why range? Range is used here because range know how to account for the Unicode code point. That is very important. So when we come here, we can for sure, this is the index, so we can say d is equal to this, and we can do index and the room itself. I am going to print another new line here again. Print it, and then let's look at it. I need to make it look, let's see, I can print new lines so we see each of them in a new line. Good, this is better. This is the first one, right? This one. So here is this new one. You see, we have the individual characters. This is at index 0 to where we are. But look at the index. The index is not 0, 1, 2, 3, 4. No, it is a little bit different because of how the internal representation is. That means and this is really important, you can't depend on the index to be 1, 2, 3. And it makes sense because each of the character here, or room, is 3 bytes. So that's why you have 0, 3, 6, 9, 12. Simple math, simple stuff. That's number 2, right? If you are enjoying the video so far, please don't forget to subscribe to the channel, please. All right, now this is the second one. Maybe this one we should create. Okay, I think we should continue. I can put example 2 and close it here. Right, maybe we should be able to fold them. Great. Now, next is in Go, strings are immutable. What does that mean? It means when you say S, let me copy something here. This time around is going to be hello world, mix of this is English and this is Chinese. All right. Strings are immutable, which means, for example, I can do this. Print and I can say S at index 0. And then I go, and it's 72. 72 because if you look at the ASCII table, let me pull it up quickly. Okay, this is the ASCII table. 72. Okay, if you go to 72, see, it is H. So this H is 72 in the ASCII table. That is the only reason why you see 72 here. If you don't want to see 72, we can use printf to print out the character itself. But let's keep it this way for a minute. You see, when we are printing out the string, we can index into it like this. It works that way, all right? But what if we want to change this first one? Let's say S at index 0. Let's say we want to change this to lowercase h. Now, this is not going to work. Go is not going to compile. Cannot assign to S at position 0, neither addressable nor a map index. This is a lot of English just to tell you that strings are immutable. It simply means when a string is created, you cannot change the string anymore. That memory space has been allocated. It's like it's been mapped out and the data is in there and you cannot change it. Technically, the way Go has. If you are doing like some pointer manipulation and all that, you probably can change it, but as it is in Go, the design says that we cannot change it. So what do we do? Well, you can create a new structure from it. Let's say, let's keep this one the way it is. And what if I convert this to, let's call it rooms, and I convert it to a slice of rooms. You know, I told you that this is managed by this room, which is nothing but int 32 here, right? And we can convert it here. Trust me, if I print their memory locations, this is P, put name, this is address of S, then address of this one. They are both in different addresses in memory. Different address. So this is a different string. It's like copying it over. Now that we have it in this structure, in this room, we can change it actually. So what we can do, you can say rooms at position 0 is noun page. Sorry, you have to use a character, and then we can go ahead and print. I'm just going to convert it to string and print the rooms. Let's put a new line here. Print, you see, hello world, and it's printed correctly. So let's do a quick recap. Strings are immutable in Go. That means you can only read it using index. You cannot write it with the index. If you want to change the string by all means, that means you have to convert it to a slice of runes, and you can modify each individual or the individual indexes. That is what it is. So this is the third one we are doing. All right, so this is really cool. I do it a lot. It's very important, it's very useful, and you should do it in case you need to change your strings. All right, so the next one I want to show is a little bit of the Unicode package itself. There is a package called Unicode, which it contains a lot of helper methods because of how Go manages strings. If you want to check, for instance, where is the, let me copy string over, let's say this one. If you want to check what is a character here, numbers, punctuations, symbols, honestly, without the help of this package, I think it will be super difficult. I'm going to show you why. Let's do our regular loop. This time around, we don't need the index, we just need the row and range over S. Okay. We can do if Unicode dot is letter, for instance, R, then we can just say it's letter. You can say C is a letter, right? We can print new line, and then we put the R here. We go and run the program, and you see G-O with this Chinese characters. I think Chinese, right? So I use Google Translate for all of them, so it's what it is. All right, so you see that this is very helpful. We can go into the function itself and see what is there. Let's go into this one. You see it's doing a lot of manipulations using the Unicode system. That is why you see that there is a lot of, let's go to the top of this function and you see something. You see the maximum, this is maximum valid Unicode code point. This is a maximum, Everything here is done using Unicode. It's very powerful implementation. And the functions are quite helpful. So you have a few of them like that. You can check for digit as well. Unicode dot is digit, you see? And then you can print, you can do anything you want to do with that. Like, let's say you want to digit, and we should have the 1, 2, 3 as part of that. If you have space, you can check for a lot of things here. So if you have like a username, for instance, and you are supporting both something like this, right? Like that, you want to support non-ASCII characters in your username, but you want the username to probably be alpha, right? Let's see if there is alpha. I don't know. Is alpha? No alpha. Is car. So there's a bunch of them like that, but for sure, just by checking its letter and its digit, you know exactly what you are expecting from that, and this is really helpful. I think imagine if the absence of these helper methods that we have in this Unicode package, I think it will be super difficult to try to code these things out yourself. So useful stuff. you can try to use them. All right, so let's look at something else again. Which is, this one is related to counting, but a little bit tricky because of how things are. Let's do this. So I'm going to close this one down, all right, and collapse this. Let's say, let me copy this over. Imagine if your user supply this as a username. Okay, let's take this as a username. Okay. How many characters can you see? One, for me, this is 5. But then the E has this acute accent. This little thing at the top makes it look a little bit weird, but it's valid. Even though it is there, this is still 5 characters. And this is if your user typed this in, maybe because of their keyboard and anything, your validation should still pass, right? It's a little bit tricky to really get this to work. Actually, that's the truth. Because now if I go ahead and say I print ln, I'm going to get the wrong number. For my system, it's showing 7, right? If we use the Unicode UTF-8, this one is showing 6. All right, this is closer. This is actually better. This one accounts for this as double, so it's a little bit closer, it's better, but the line is actually way off, so you don't even want to depend on that. So how do you solve that problem? Now, there is, the solution is a little bit tricky. So there is a package which I'm going to include, github.com. In case this is the digression a little bit, if you need the HTTP library, I have one on GitHub, HTTP lib, and this is github.com /HTTP lib, fantastic library. So I'll go to Revo and this one. This is for my ID. I'm going to try and put something like this. Let's just do something here. I'm going to, even though it is not valid, I want to do that so I can do go mod tidy. Go mod has installed it. I can close it now. This library by Revo Uniseg, it's really useful library. So let's use it. There is and if you want to go into the technical detail of this, you can Google how to handle, let me type it, how to handle graphene clusters, something like this. Just Google something like this. So it's a little bit technical, but for sure we don't have to worry much about this because this library already does the job for us. Okay, so I can say graphene cluster or something like that. Unicef.new graphenes. So we are going to turn that username into graphenes, and let's count how many real characters that we have. So the graphene.net, this is like, I don't know if you have done like a linked list or anything, this is how to continue scanning, and I'm going to just increment the count here. gr.next. Okay, I missed 4. All right, and then I'm going to come here and say print count, and you come here, we can run the program, and you should see 5. Now this is the correct one. So if you want, you can, let's say, func count char, and we can take a string or slice of room think we can return int. Let's bring this in here. Okay. Instead of, so if you want, you can wrap this in a function and that becomes really easy to use. And you do that is print number of chars is number of characters is this and username. Okay, let's take this from here. Okay, so we already did this here. Okay, and then let's run the program now. Right, this is it. So even your user, this is when they put this in your maybe form input or something, this is going to pass validation. Really, really good. Really, really good. This function, don't forget, this is the name of the package. Very useful package. Yeah. So I'm going to comment this out one more time, and we can look at the last one, which is, I want to show you, how do we reverse a Unicode string? So let me come here. I think we can bring out one of the letters that I have. So let me copy out one of the text. This is a string, right? We need a way to reverse it. Let's say reversed equal to ref or something like this, s, and we can print it out. Okay, reverse. Now this ref, or maybe we can just name it reverse. This reverse, let's come and implement it here. Okay, func, it takes a string of s, and we're going to return a string, simple function. We need to bring this one, we're going to use it again, gr, new graphics, okay, s, so we have it now, graphics, the slice of string. Then let's scan it. Let's do the same thing that we did earlier. Let's scan everything into it. So what we're doing now is we just want to do we're gonna get a string of this and then push them into this. There should be, I wish there is a way for us to just say this slice dot put. Maybe I should write a library that does that. Append. We are going to append the gr.string. Okay. At this point, we have all the strings in there. Okay, so let's work with it. Old classic stuff here. Initialize this to 0, then the line of the graphing. There's nothing special here, just some old okay, and then j equals to I plus 1, j minus 1, something like this. Let me see if it's correct. I initialize this I and j to 0, and then our loop count len graphings minus 1. Okay, so I need to do this here. Yes, and then I less than j, Then yes, okay, that looks okay to me. I want to do it in place, so I can say probably a cleaner way to do this instead of these double loops that I'm putting in one place, which can be confusing. But I don't want to do like multiple. We can use our friend printf. Okay, why? I can just say string, right? Graphing. Okay, why? Oh, okay. Let me do form.print graphing. Okay. Simple stuff, classic old loop. Let's run the program. Since we have it set up here already, we can run it and see how it behaves. And we have it. All right. But instead, it's a little bit weird, right? Let me see if I have made any mistake. Yeah. Let's see. First one, hello. So yeah, comma, yeah, this is correct. The original one is this one and this. So let me come down a little bit. Now, the most important thing here is the fact that we're using this library. Without this library, it becomes a little bit tricky to get right. So you should, you see, we have this done correctly here. If we don't use this library, you know what is going to happen, right? We won't be able to count it correctly with len. So we cannot work with this directly, like maybe turn this into a slice and then start counting directly, or using len on this directly. This is going to give us a wrong. In short, we can try it. We can go ahead and do it. And boom, it crashed. So you shouldn't do that. You shouldn't do that. Actually, when the first time I tried to do this, I didn't know about this library, right? So I was struggling with it until I found this library, and that's why this is because of that library that I made this video, and of course some of the interesting stuff. So yeah, I think the video is going too long, so thank you for watching. We looked at some really great stuff, the difference between the length in bytes and the real characters. Using UTF-8 to count the real characters is really important. Strings are immutable in Go. If you want to modify them, you can turn them to a slice of runes. And then how to use a Unicode package to check for letters, digits, and many other stuffs. And now the cute accent, you can use this library by Revo to help you do the counting properly and account for this acute accent. And then we also did the reversing of the Unicode character. So basically that's it. Thank you guys. If you love my videos, please don't forget to subscribe. Bye.